So it's not working, but that's okay. All right, so if you look at your notes, we're going to start with SIGDIG, so you can open up yours and take notes as we go along. If you are confused the first time you hear this, that's normal. So if you're a little bit lost and it doesn't make sense, that is normal until we get used to it and practice it some. So if you get it the first time, then that's really good. But if you're confused, then don't be surprised. So we're going to go through this. I don't know why the webcam's not working, but I don't really care, so we'll just close it. All right, so SIGDIGs, we talked about a little bit when I showed you the ruler thing, if you could see it. The more accurate your device is, the more SIGDIGs we have. So we're just going to work on counting how many SIGDIGs there are, and then we'll go through the math involved with SIGDIGs. So first are the rules. Oh, this should come up one at a time, but it didn't, so I don't know. I don't know if it's worth trying to set them now or not. Animations. There. All right, so the easiest rule, the best one of all, that is easiest, we like this one, is all non-zero digits are significant. So anytime you don't see a zero, it's really easy. So all we're doing is counting the digits of a number and saying which ones count as a significant digit. So we'll get it working. So any number that's not zero, 1, 2, 3, 4, 5, they all count. So there's 5 significant digits. I abbreviate it SD so I don't have to write SIGDIGs all the time. We just say SIGDIGs. So any non-zero numbers, so the number 24, there's 2. It doesn't matter how big or how small the number is. If there's no zeros, they all count. So this huge long number, the first one counts, the last one, they're not zeros, so everything in between counts. So if you see the first one's a number that's not zero, the last one's non-zero, so everything in between has to count. So if you add those up, there would be 12. So that's 12 SIGDIGs. So that rule is pretty easy. Next. Come on. So rule number 2, also not too bad. A zero, zeros are the confusing part of SIGDIGs. So if there's zeros sandwiched between non-zero numbers, then they will be significant. So zeros sandwiched between. So here's 2 non-zero numbers. If the zero is in between, it will count as well. So if the first number, last number are non-zero, everything in between counts, no matter what. So whether they're zeros or not, if they're sandwiched between 2 numbers, then they count. So that has 3. Same thing, it doesn't matter how many zeros you have. If it's between 2 numbers that count, then everything in between is going to count. So all 4 of these zeros count because the 2 and the 3 count. So this has 6 significant digits. So the number in parentheses is just us counting how many there are. Same thing, so it could have 1 0 like the first example. It could have a number in the middle. It could go every other one is a 0. It doesn't matter. If the first number is significant, the last number is significant, everything in between is significant. So whether they're zeros, whether they're non-zero numbers, everything in between counts. So you don't necessarily even have to look at zeros. You can just look and say the first one counts, the last one counts, so I can just count everything in between. So zeros in between numbers that are significant will be significant. The third and fourth rule are the ones that people get confusing. It's starting zeros and ending zeros, but this will simplify it. Just remember, any starting zeros, whether there's decimals or not decimals, usually you always see starting zeros with a decimal, but starting zeros never count. Doesn't matter how many starting zeros you have, they never count. So some people don't even write that as a zero. Some people will just write this number as 0.52 because the zero doesn't matter. It's not significant. The second example, these are just placeholder zeros. So these beginning ones are just placeholders. You could write this as 5.2 times 10 to the negative 1, 2, 3, 4, 5, 6. So if you converted it into scientific notation, you could do that and it wouldn't make a difference in your number. So it's 5.2 times 10 to the negative 6. Yay! You can just set it down. Thanks. All right, and then the last number has even more zeros, but starting zeros never count. So it doesn't matter how many zeros you have. I didn't even count how many when I made this example. I just typed a bunch of zeros. So if you were handwriting the notes, you could have put 100 zeros, you could have put 50 zeros, you could have put 1 zero. Doesn't matter how many zeros you have, starting zeros never count. So this still just has 2 sig digs. All right, so those are the first 3 rules. So far, not too bad. Just remember, starting zeros never count because those will get kind of in the way. So anything that's not a zero, they always count. Zeros in that are sandwiched between, they always count. Zeros in the front never count. They're just placeholders. So starting zeros don't count. Rule number 4. Sometimes I will break this into 3 mini rules because there's different ways that it looks. But your main thing is ending zeros only count if there's a decimal point involved. Or we'll talk about it in the next rule. There's a bar above a zero. But ending zeros are only significant if you see a decimal point. So we had our starting zeros at the beginning, they don't count. Ending zeros, so zeros that are at the end of a number. Sometimes if you look it up online, they'll say trailing zeros because they're at the end of the number. I just call them ending zeros. So anything at the end, if there's no decimal point, they don't count because those are just placeholders. So if it doesn't have a decimal point, they're just placeholders. It's like saying you rounded this number, the first number, to the nearest 1,000. So we just rounded that number. Or we're saying our measuring device wasn't that accurate. It was accurate to the thousands. So this one has 2. If it has the decimal point, now we're saying that our measuring device, or we counted or whatever, to the nearest ones. So this is accurate to the nearest ones. So now we're saying that this is significant to the nearest ones spot, where the first one was nearest thousands. This is the nearest ones. So that makes everything there significant. So we have 5 sig digs. So if you see a decimal, it makes the zeros at the end significant. The decimal could be right at the end of the number, like the second example, or you might see the decimal, like the third example, sandwiched between zeros. All of those zeros are still ending zeros, and there's a decimal. So every one of these zeros are going to count. They're all ending zeros, and there's a decimal. So they all count. So these 2 numbers count because they're non-zero. And then these are all ending zeros. And there's that decimal point right there. So it makes them all count. So ending zeros with the decimal all count. So there's 7 sig digs. The last one sometimes gets people because the zeros are after a number and the decimal's way out front. This 0 doesn't count, remember, because it's a starting 0. So that's where people start to get confused because they see a decimal point and a 0. But remember, this 0 is a starting 0. So it doesn't count. Then these numbers count because they're not 0. The last 4, these are trailing or ending zeros. So you look at their ending, and there's a decimal point. I know you guys know that's a decimal point, but I'm just trying to make a point. So they're ending zeros and a decimal point. That makes these count. Whether they're directly after a decimal point, like the other examples, or directly before, or the very end, 10 digits after a decimal point. If they're ending zeros and you see a decimal point in the number, they count. So those ones will count. So that makes 7 sig digs there. Good so far. All right, so one step at a time. Again, if it doesn't make sense, sometimes they don't. You just have to hear it over and over and do lots of examples. So, all right, don't look ahead because, again, I didn't put it on the right thing, but that's okay. If you have a number that's in scientific notation, all the same rules apply. You just ignore the times 10 part of it. So ignore the power of 10. So I only put one example up because we've pretty much done all of the rules. So here's the number. We're going to look at this number. Scientific notation, you don't worry about that. That's just going to apply placeholder zeros to get your value where you wanted it. So anytime you want scientific notation, you just ignore the power of 10. That's also a way that you could get the right number of sig digs with a number with lots of zeros is by putting it into scientific notation and then just having the number of zeros you need to have the right number of sig digs. So when we're counting this, ignore the power of 10. It's still part of the value of the number, but not for sig digs. And then count the 5, the 2, and the 3 count because of the first rule. The 0 counts here because it's smushed in between, and because it's also a 0 after a decimal. The last 0 is an ending 0, and it's after a decimal point, so it counts. So any ending 0, if it's after a decimal, it will count. So there's the reasonings why we have 5. Number 6. Again, these are the way I write out the rules. If you look them up online, sometimes they get really confusing, like to the left of a decimal and after a number, and to the right of a decimal and. So sometimes they get confusing. Maybe it will help you. If you don't understand these, maybe it'll make it worse. So if you understand these, I wouldn't look up rules online. If you don't understand these, you can try to look them up and see, but usually the wording in books and online is more confusing. I've just, over the years, kind of shortened it to this stuff. Number 6, if you see a bar above a 0, the bar can only be above a 0. So don't try to take a shortcut and put a bar above a non-zero number anytime, because you'll only see a bar above a 0. That will let you know that that's the last significant 0 in the number. The other way you could show sig digs with lots of zeros is with scientific notation, which is what I was trying to say in 5, but it probably sounded confusing. So in our number, this number, 5 million, if we wanted to round it to the nearest hundreds spot, but they're all zeros, or we wanted to round it to 5 sig digs, so if you count 5 sig digs, 1, 2, 3, 4, 5, that would get you right there. So There's our 5 sig digs. If you were trying to round it to 5 sig digs, you can't just drop off the last 2 zeros because you changed the value of your number. So to show that this 0 right here in the hundredths spot is significant, you can put that bar above that last 0. So that tells you that that's a significant figure, and the rest don't count as significant. They are placeholders, so they are there. The other way to write this number, I'm going to do it over here, with 5 sig digs would be to put it in scientific notation. So you could put 5.203 times 10 to the, and however many times we move the decimal, 1, 2, 3, 4, 5, 6, 10 to the 6. So I don't know if you guys remember scientific notation or not, but if you move it to the left, the decimal or the exponent increases. When you move the decimal to the right, the exponent decreases. So that number you could rewrite, and now you can see there's 1, 2, 3, 4, 5 sig digs, and that's how many we wanted. So you can do either one when you have zeros involved. You could write it in scientific notation or put the bar above a 0 when there's lots. So this other example with 2 million, we have 4 sig digs. So the line goes above the 4th number, 1, 2, 3, 4, which is, whoops, I did that, which is the 3rd 0. Or you could put it as 2.000 times 10 to the, that point's really hard to see, but it was given me a weird box. There we go. 1, 2, 3, 4, 5, 6 times 10 to the 6. I guess that makes sense since they're both million. That's good. All right, so the last thing are conversion factors. We'll get here when we do our math problems with sig digs involved in the answer, when we want to put our answer to the correct number of sig digs. We'll need to know that when we use a conversion factor, there's actually an infinite number of sig digs. So if we say there is 1 minute and 60 seconds, or we say there are a dozen of something, if we're counting something, so if we say 1 dozen eggs, if you count something, there's 2 basketballs, then that's an infinite number of sig digs, because there's exactly that much. There's not 2.01 basketballs. So there's an infinite number because it's an exact known quantity. So I could say there's 2.0000 and put as many zeros as I want. So when we say there's 1 minute and 60 seconds, if there's 60 seconds in 1 minute, we could actually write it as however many zeros we wanted, and 60 point however many zeros we wanted for seconds, and go on forever. We just don't write that because we don't want to write a million zeros after all of them. So if it's an exact known quantity, such as conversion factors, or if we're counting something, so I guess this could say counting too, so like a dozen eggs or 2 basketballs. So if you're counting, running out of room. So exact known quantities or counting something out, then it would be infinite. If you're estimating, like there's 300 people at the football stadium, that's estimating if you say there's about 300 people. But if you counted the people as they came in and said there's exactly 295 people here, then we know there's exactly. Questions on counting? All right, so I'm going to give you just a minute to go through in your head and see how many, if you can go through and guess how many sig digs each of those numbers have, and then we'll go over it. So just going to pause for a minute. and let you guys try that. All right, so if we look at, I've lettered them so that we could go through them. If we look at letter A, you should, how many did you guys get? 4. Okay, so you should have gotten 4. The first ones are starting zeros, so they don't count. And then this one, this 0 is sandwiched between. So all these ones will count. So you should have 4. The next one, we have, what did you get? So 5 counts. 2. So we at least have 4. This 0 count. All right, and then this last 0 is an ending 0, but there's no decimal point, so it doesn't count. So this one we're going to have 5. The next one, letter C, these 2 count. The rest are all end zeros, and there's a decimal point, so that's going to make all those zeros count. So 1, 2, 3, 4, 5, 6. So this one you should have 6. All right, letter D, we got all the numbers that count. The zeros between count because they're sandwiched, so we have to deal with this 0 right here and see if it counts. So it's an end 0, so go back to the end zeros. If there's a decimal, it counts. No decimal, it doesn't count. This has a decimal in the number, so it counts. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9. All right, letter E, we have the 2 and the 4 that count, so everything in between counts. And then we have our zeros here to deal with and our 0 there. The first zeros are starting zeros. So starting zeros never count at all. So just think of them as always starting. And then this 0 is an end 0. So look at the number. If it has a decimal, it does, so the 0 counts. So ending zeros count with a decimal. So 1, 2, 3, 4, 5. So that one has 5. Right? So those should be your answers. 4, 5, 6, 9, 5. So hopefully we're not too bad. Questions? All right, so we're gonna continue and look at how we do the math involved with SIGDIGs. Let's see how that goes. Oh, we'll do rounding first, I forgot. So now if we have to round a number to however many SIGDIGs that it tells you. So if you're rounding, if it wants you to round to 4, you find the first number that counts and count to 4 and round to that place. Or if it wants you to round to 2, you count 2 SIGDIGs and round to that one right there. So that's, I guess, the first thing. These are just the rules. So find the first non-zero digit and count to however many SIGDIGs you need, and then round. So if you have starting zeros, you don't want to count that as SIGDIGs. So that's basically what the rules are saying. So here is our number, and we're just going to go through and round it to 4, 3, or 4, 5, 4, and 3 SIGDIGs. And then it has 2 and 1. So if we want to round it to 5 SIGDIGs, you take your starting number and count, find the first one that counts, which is there. And then 1, 2, 3, 4, 1. I don't know why my 1 disappeared. 1, 2, 3, 4, 5. So we've got to round it to the 5th SIGDIG, which is right here. Right here. I don't know why my arrows are disappearing. Okay, the number after it is a 7. So if it's 5 and above, we're going to give it a shove. So 57 is going to round up to 60. You have to put a 0 in there as a placeholder. You can't just drop it off and say, I'm not going to put this 0 there. Because if you didn't put a 0, 5, 4, 2, 2, 6. So if you didn't put a 0, all of a sudden you changed your number from 540,000 to 54,000. So you can't do that because you changed the whole value of your number. So make sure you always put zeros in as placeholders. Remember, as long as you don't put a decimal at the end of that number, that 0 is not significant. So don't add decimals, so we don't add significant digits, so you'll be okay. Rounding it to 4 SIGDIGs, we take our same number, but now we're rounding it to the hundredth spot, which is that 2. So you look after the 2, it's a 5, 5 and above, give it a shove, so you have 542,300. Again, putting zeros in as your placeholders. Rounding it to 3 SIGDIGs, do the same thing, you count over, now we're counting over to just 3, 542,000, so we're rounding to the nearest thousands. The number after it is a 2, so you let it go. Right here, let the rest go, so you fill in with zeros and you get 542,000. Questions? Okay. On any of that? So I can just go over one. Okay, so 4 SIGDIGs, I'm going to rewrite the number. 5, 4, 2, 2, 5, 7. So if you want 4 SIGDIGs, count 1, 2, 3, 4. So I need to round it right here. So if I'm rounding 257 to this place value, it's going to become 300. So I have 5, 4, 2, 300. So now this number right here has 1, 2, 3, 4 sig digs. So then you just here it's just rewritten with 4 sig digs. So as long as you don't put a decimal here, if I put a decimal, that makes these zeros count because they're trailing zeros or ending zeros. So don't put the decimal. Oh, it disappeared somehow. I don't know. Don't put a decimal there, and they won't be significant. So we did the same thing with 3 sig digs, and we'll do the same thing with 2. So we'll look at 2. 5, 4, 2, 2, 5, 7. So that's our original number. Count over 2 sig digs. 1, 2. We need to round to that place value. The number next to it is a 2, so we're not going to round it up. So since we don't round up, it stays 54, and these all become zeros that are not significant. So we get 540,000. Sometimes it's easier to think like back what you would have done a long time ago, like with 5 sig digs, count to 5, but remember back it would say round to the nearest tens, round to the nearest 100. Sometimes it's easier to think place value once you figure out what place value 4 sig digs would be. So if back in 2nd or 3rd grade it said round to the nearest 100, then you would round to just the 300. Or here, if it said round to the nearest, this one, 1,000, then you would look at this number round to the nearest 1,000, which would be 4 sig digs. So 1 sig dig is the nearest 100,000. So the number after it's a 4, so you just have to round it to 500,000. Question? All right. If they were decimal points, there we go. So if it was a decimal point and you wanted to round it to 2 sig digs, remember, because at some point on a test, people will always put the answer as 0.00 and be done. Remember, starting zeros don't count. So anytime you're doing this, find the first non-zero number. So whenever you're counting sig digs, always find the first non-zero number and then start counting. So there's 1 and there's 2. So there's the 2 numbers that I need to write down. I just need to decide whether the 4 rounds up or stays the same. So the number next to it, 0.0002, and then the number beside it's a 5, so we're going to round the 4 up. I almost wrote it right where it was supposed to be. All right, and then rounding that to 1 sig dig. So if we get rid of that, we want to round it now to 1 sig dig. So you still need the starting zeros that don't count, and you should get 0.0002. So it's not going to round up. Oh, this is why I did this example. Make sure when you do this, particularly like on a test or something, when you're rounding to 1 sig dig, look back at the original example. Don't look at the one that you just rounded. Because if you look at the one you just rounded, you get a 3, but that's not our original number. So make sure you're always looking at the original number when you round it to the next place. That's why I did this one. Ready for math? Okay, so the reason we need sig digs with math is because your answer can never be more accurate than any of your numbers, which I'm sure it probably says that. Yeah. So your answer can't be more accurate than any numbers that you're adding. So if I am measuring things to the nearest tenth, and then all of a sudden I give you your answer to the nearest, like 5 decimals out, it just doesn't make sense, because I'm only measuring to the nearest tenth, so why would I give you an answer out to 4 or 5 decimal places? So that is our whole premise here. The only bad part is there's different rules whether you're adding and subtracting or you're multiplying and dividing. So we have to keep those two straight. So that's the only bad part. So if we add and subtract, we have one set of rules, and if we multiply and divide, we have another. So when we add and subtract, we're going to think place value. So we're going to have to think whether it's to the nearest tenth or the nearest 100, the nearest 1,000. We're going to think place value. And then you always go to the least accurate measurement, whether it's adding, subtracting, multiplying, or dividing, you always go to the least accurate. So always think place value for adding and subtracting. No matter what, we're always going to the least accurate. Sometimes it's easier to write the examples. Try to get a darker color. Sometimes it's easier to write these examples up and down. So if we are adding these 3 numbers, we look and see which one is the least accurate number. So our first one is accurate to the nearest hundreds. Oh, I don't know why I put a big line across, but that's okay. The second one is accurate to the nearest tens. And the last one is accurate to the ones place. So you want to go to the one that is the least accurate. So our least accurate place value is the hundreds. So we should be rounding our answer to the nearest 100. So we still added up. 7 is 14. So I think that's what you get when you add it, but my brain doesn't always work, especially on Monday. But if that is correct, then we want to go to the least accurate, which if this 7 were just underlined, I don't know why I underlined the whole thing, but so you go to the least accurate place value, which is the one to the leftmost will be the least accurate. So we would round to the nearest hundreds. So our answer would be 63,500. So we don't want anything more accurate than our least accurate measurement. Sometimes it's easier with decimal places because then you just look at the one with the least amount of decimal places. So a lot of times we like decimal places because it's way easier to count decimal places. 5 because we just line up decimal places and then it's easy to see. 4, 2, 3. All right, so this is a long one today. 54121 plus 5.8. 4 plus 8.5. My board's starting to mess up because it's giving me random straight lines, but as long as it's not totally messed up yet, we're good. All right, so the first one's 5 decimal places out. The next one is 3, and the last one is 4. So we want to go to the least accurate, which is 3 out. So it's actually to the 3. So we want to round it to the nearest 100,000th. So the nearest thousandth or the third decimal place. So 16.92.924. Okay. So adding and subtracting, think place value. So we want to go place value when we add and subtract. No, you don't want to add zeros because it's after the decimal place. But if it's before a decimal, so the first example, we add zeros so we don't change the value. But after the decimal, you don't, because otherwise, if we added zeros, they'd be significant. So that was a good question. I don't know, at home they probably didn't hear, but after the decimal, do not add zeros. If it's no decimal, you have to add zeros. So the first example, we had to. Any other questions right now? People at home, you have to email me your questions. So, all right. That is adding. Subtraction works exactly the same. I usually just don't do subtraction examples because I don't like to subtract as much as adding. So that's pretty much the reason. Okay, multiplying and dividing. Same thing, your answer has to go with the least accurate. But when we decide the least accurate with multiplying and dividing, we have to think sig digs. So we're counting sig digs in each of our numbers. So where before we counted place values, now we're going to count sig digs. This just sounds or says the same thing basically. Your answer needs rounded to the least accurate based on sig digs. So here's our two numbers, 4.2 times 2.11. If you multiply that, you get 8.862. So to get your final answer, you count how many sig digs each of your number has. So we want to make sure we really know how to count sig digs. This is nice because none of them have zeros. So 4.2 has 2 sig digs. 2.11 has 3 sig digs. Your answer needs rounded to the one with the lowest. So 2 is the lowest, so your answer needs 2 sig digs. Again, I don't know why my board puts a random straight line, but it is. So you need to round 8.862 to 2 sig digs. So your final answer to 2 sig digs, we need to round to the nearest tenth. So 8.9. Me, multiplying and dividing is much easier. I don't know. I think it's easier to count sig digs than worry about place value. But okay, here's our big mathematical, like, horrible thing. 5 times 5 is 25. 5 has 1 sig dig. 5 has 1 sig dig. So we've got to make sure 25 has 1 sig dig. So there's our 1 sig dig. So 2, 5, 25 would round up to 30. So really, this whole time in your whole life, 5 times 5 is really 30. Yeah. But if you're in physics, according to rounding rules, 5 times 5 is 20 because they round all their 5s differently. So in physics, you'll get 20. Because of statistical rounding, you get 20. If you don't use statistical rounding, you get 30. And in math, you get 25. So there's a whole bunch of answers. Yeah. So 5 times 5 is 30. Dividing works the same way. Oh, here. If you wanted 5 times 5 to be 25, you could put 5.0 times 5.0, because then you get 2 sig digs and 2 sig digs. So 5 times 5 would be 25. And that would be 2 sig digs. So there's your way to get 5 times 5 is 25, is to put 5.0 times times 5.0. Then each one would have 2 sig digs. Dividing works the same way. So if you had 90 divided by 10, each of those is 1 sig dig. So you have 1 sig dig on the top, 1 sig dig on the bottom. When you divide, you get 9, which is 1 sig dig. But if you had 90.0 divided by 10.0, each, for a minute I thought I divided wrong, so I double checked, but 90 divided by 10 is 9, right? Just making sure. Each of these are 3 sig digs. So your answer would have to have 3 sig digs, so you put 9.00. So if you need more sig digs, like when you divide, you get 9, but we need 3 sig digs, so you put 0.00 to come up with all 3 of your sig digs. Questions? All right, then what we have, yeah, I guess we'll keep that. If you go to your Google Classroom for today, then you'll see the notes, but then you see the worksheet. So here's the worksheet. The only thing that people get confused with, so first you're going to say how many sig digs there are, and then in number 2, you're adding and subtracting and trying to get the right number. So we can go over this tomorrow to make sure we have this right. So you're going to attempt and try, and then we'll go over it to see. In number 3, you're multiplying and dividing. Number 4 combines them, so you have to do your order of operations. So if it's in parentheses, get your sig digs right for that first, and then divide. 5 is where you round. So you are rounding them each to 2 sig digs, but if it already has 2 or less sig digs, you put an X in the box. So if it's already 2 or less, you can just put an X in the box. And then 6 is giving you a value for X and you find Y. I don't know why it just doesn't put, I don't know, but so there's some multiplying and then you add 32. This is actually the equation for turning Celsius to Fahrenheit. So in case you cared or wondered, but so that's what we're going to do. Practice sig dig. So if you need a calculator, I would use a calculator for the numbers and then just round to the right number of sig digs. All right, if you have questions, make sure you ask.